All right, my name is Suresh Dhaniyala. I'm an associate professor in the mechanical and aeronautical engineering at Clarkson University. My research interests are largely on airborne particles or aerosol particles, and these are particles that are everywhere, ubiquitous. They are of concern from an air quality and human health perspective, from an atmospheric point of view with respect to climate change and other aspects related to that, but also in industry related to filtration and semiconductor industry, because these could be contaminants that you want to get rid of. Our focus in this lab is largely concentrated on trying to build newer, better equipment and to be able to use these equipment for good scientific studies. So we've got a lot of these instruments that are, for example, differential mobility analyzers that are commercially available, and ones that we custom build. And these instruments allow us to be able to study particles down to about 2 nanometers in size and all the way up to several micron, up to nearly 100 microns. And the applications, we're deploying these instruments, for example, to study the characteristics of diesel emission particles from the latest engines that are coming out. A lot of these particles are really small, below about 20 nanometers sometimes. We are also deploying these instruments on aircrafts. We fly with scientists at NCAR and NASA to study atmospheric aerosol and see how these particles that we might be putting out from human activities are influencing cloud formation and through it climate change. From an industrial perspective, these instruments can operate at pretty low pressures, go to very small sizes, which means as the semiconductor industry starts focusing on smaller particles from a contamination control point of view, as the critical sizes start getting to sub 50 nanometers, these kinds of tools I think are going to become really useful. They can sample from very low pressures and provide us with size distributions under airborne conditions without really needing to collect them on substrates, etc. We can get the size distributions in a matter of 10 seconds, 20 seconds, 30 seconds. So very fast measurements that can help us, for example, in process equipment, detect transient particle formations and so on. So to just briefly conclude here, these instruments, the latest generation instruments that we are working on in this lab here, ones shown here and some even smaller equipment that we can wear, I think will become really important as we start addressing challenges that are going to come up in the next few years and the next few decades, I think. So thank you for your time, and hopefully I've interested you in our research here.